That way you can get to the next one a little bit on time, hopefully. So my name is Dan Clark, and I'm here to talk to you all about database testing with PyTest. I apologize for the colors. It's not me, it's that. But first, I just want to just kind of throw out a thanks to my family, basically my wife, Ricky, my kids, Andrew and Natalie. It's my daughter's birthday tomorrow, so it should be interesting. But without them, I wouldn't be here because they've been pushing me along with all this. As an FYI, as you can see, I have the code up on GitHub, and I have a companion article as well. And I'll also have a link to it at the end as well. So who am I and what am I talking about? So basically, this is for the person that I was a few years ago. More or less, I kept on taking up the role of the accidental DBA at every place that I kind of worked at. So I'm not really a DBA, but I kept on being the guy that everyone went to whenever there was a database problem. So at one point, I landed at a small business where we didn't have that many resources, and I had no one to ask questions about, so I had to kind of discover all this stuff on my own. Of course, Google wasn't really being helpful in regards to database testing, and what I needed to do, we had a system where all of our business logic were in stored procedures. In fact, one of our core stored procedures were over 4,000 lines long, and making any changes to that stored procedure was kind of nerve-wracking because make one change, you could break something else. So I wasn't sure where to start with testing out this massive stored procedure, and I needed to find a way to do it. Again, the system was just dropped in my lap, and I had a desire to implement some sort of automated testing so that I could be comfortable whenever I made any changes to my database. And over the last 5 years or so, I kind of came to this approach. But first, so what is unit testing? I'm just going to go over that really quick. Basically, the idea here is we're talking about the method of individually testing the smallest parts of a software system. This means isolating functions, and then running them against sets of conditions and checking to see if those results from those tests match up with our expectations. Tests can pass when those results match up with our expectations, but a test could also fail when either those results don't match or an error pops up when we're testing out some part of our system. Now, in regards to databases, we have a number of things that we can test. We have views, tables, table constraints, functions, stored procedures, triggers, but pretty much anything that's responsible for some sort of decision can be tested against. And that was one of the things that I had as a challenge, especially with my 4,000 line long stored procedure. I needed a way to come up with a reliable way of testing out all that logic. So that's nice. How was I going to do it? Wow, that's really bad. PyTest. So what brand projector is that? Sorry. So I'm not going to go over all the details with PyTest, but basically the idea here is there were a bunch of options out there. A bunch of them were specific to databases. For example, Microsoft SQL Server, if you're from that world, there's T-SQL-T. There's a whole bunch of options out there. And I'm not going to go over them because that could go on for more than 25 minutes. Now, we did have some great success with PyTest in our application testing. So I figured, why not see if we can use it for testing out these stored procedures. The things about PyTest, it has a great documentation set, great IRC channel, and it has a great community as well. It has that Python feel that we all love and appreciate. So I'm hoping everyone's sold on the fact that I went with PyTest here. Now, I'm not going into the details, but please do review the docs. They have the documentation on PyTest is fantastic. However, there are 3 parts I will go over, which are fixtures, tests, and then just basically how to run PyTest itself. So first things first, there are a few caveats to my approach here. With unit testing, with unit testing, we need to set up the environment before the tests are run and then tear them down afterwards so that we can reset the tests or reset the environment for the next test, right? We're going to do that with transactions. In an ACID-compliant database, transactions meter the flow of updates and inserts into our database. So we can leverage that to augment the setup and teardown processes. Also, transactions ensure the integrity of the database. This means that a change won't be persisted unless we want it to be in there. Again, we can use this to our advantage, and we can undo the changes that we are making with our database as we're testing it. As an FYI, I'm going to be starting with an empty database. So that means that the structures all going to be there, the stored procedures are going to be there, but there's not going to be any data in the tables. The idea behind this is I want a controlled environment where I can put data into my database, run my tests, and not be surprised by anything that might be coming from my production database. So for example, I'm going to be looking for how many rows is this stored procedure, or how many rows is this stored procedure returning? Is it returning the right amounts? And that sort of thing. So that brings us to the fixtures part of this talk. So fixtures are Python functions or methods that can be used to set up the conditions for our tests. In this pseudo example that we have oh wow. I promise there is, oh shoot. Yeah, maybe that might help. Can you lower the contrast? We tried that at the last, is there anything we could, no? All right, so anyway, I'll read it off and hopefully, yeah. So at the top of that, if you can see it, it says pytest.fixture. And what that is, that's a decorator that just is basically telling PyTest, hey, this is a fixture, bring it into your library of fixtures so that we can use them in our tests. Next, and you kind of see that there, it's a yield some object. So that's going to be, so before that we have the code. You can kind of see that comment where it says set up some object here. Basically that's where the code is going to live to set up the object, and then we're going to yield out that object to our tests. And then afterwards, after that yield, we have some code to just tear it down afterwards. Now remember, we are going to be using transactions here, so we're going to be using a rollback actually to clean up after our tests. This is going to be bad. All right, sorry about this. So the idea here is this is a test, or kind of. But the general idea here is that this is a simple test to check on the database. And what you can't see is basically, it's the name of the function is test underscore project steps tables exists. So the idea here is that test underscore that's on there, that tells PyTest that this is a test that it should be running when we invoke it. Also within the body of this, which you can thankfully see, is a query to our database, which is basically just pulling back an ID from the project steps table, and then the cursor fetch all, that's going to pull back that result set, and then finally we have an assert that's going to take a look at that row set and just make sure we have no rows on that row set. This is just kind of a litmus test. It's just meant to just check that everything is the way it should be. Now, there are some helpful PyTest options. So when you go to run PyTest, these are the things that I've used generally to make my life a little bit easier. So -s, basically that allows us to actually see print statements. So for example, if you have print statements in your tests or in your logic, it will actually allow those to bubble up to the console so you can see them. -m is for marking your tests. So if you had a collection of tests, you can set a decorator on each one of those tests that marks it as a certain name. And then when you go to run PyTest, you pass in the -m with a name. And that allows you to see or run certain tests. --pdb, basically whenever we run into an error, we're going to basically drop into the Python debugger, which is a great tool. If you're still using print to do debugging, try out PDB. It's awesome. LF. So if you have a whole bunch of tests in your testing suite, so let's say you had 60, maybe 100, or even more, depending on how complicated your test suite is, You don't want to run all of your tests if you only had like a handful fail. So the idea here is LF will only run the tests that failed. This is a really helpful command or option when you run PyTest. And then finally, because I don't like dots, because I like to see the names of which ones fail, I'm really into instant gratification. -v just kind of shows us the names of our tests and allows us to see which ones pass and fail as they're running. All right, here comes another code slide. It's on GitHub, I promise, I think. So let me try and read most of this off to you. So basically right here we have, so these 3 fixtures are all that PyTest needs. Basically what we're talking about is a password fixture, a connection fixture, and a cursor fixture. So the first one isn't really needed, that's our password fixture. I'm just using that because I don't want to hard code my password into my test suite. So the idea there is I'm just reading it from a file which can be secured and all that fun stuff and not get committed into our repo. Again, don't commit your password to your repo. The second one, that's our connection fixture. So the idea there is we're setting up the connection that PyTest is going to use to actually access the database. And then you can kind of see that it's going to be closing the connection after it yields. So when we're done with the fixture, we're going to actually close the connection. And then finally, we have the cursor. So this is the actual fixture that this is going to be doing all the heavy lifting. It's going to be executing our SQL against the database. And then at the end of that, there's also a rollback as well. That's going to be responsible for resetting our database to that empty, clean slate so we can populate it with more data for our next test. Sure.
Rollback done a commit.
Sorry.
So is a rollback only useful if you haven't committed?
Well, so you can implicitly just roll back. So the question was, sorry, come back one more time.
So if you do, say you do an insert statement, and you attach that to the cursor, but you haven't committed that, you haven't done cursor not commit. You're confusing. Go ahead.
All right, afterwards. All right, we'll talk about it afterwards. Basically, here I'm explicitly rolling back so the database can, after each test, wipe out the database and start with that fresh, clean slate. So, really quick, a word about scope. Now, the one other thing too that I want to do here is I want to reuse a single database connection instead of setting up a new database connection with every test. Well, you probably didn't see it, but on our connection fixture, we have on our fixture decorator a scope equals module. That means that the connection fixture will stay, it won't get cleaned up at the end of each test. So what this means is it will basically stay in memory and it will maintain that connection with each test. So a little bit more speed when we run our tests. All right, so where do we want to put these fixtures? conftest.py. So conftest.py, when I first started doing this, I was putting all my fixtures into just a file and then importing into the test. With PyTest, that's a no-no. So you want to use conftest.py. It's a magical place where PyTest goes to find all its fixtures, it registers them, and then you can use them in your tests and pass them to your tests as parameters. If you have too many fixtures, like I ran into that problem, I would take the fixtures, put them into separate files, and then import them into my conftest file. That was my way of getting around that. So another code slide, apologies. Now that we have our 3 fixtures, here are fixtures that you can barely see that will set up our database before each test. So the idea here is you have a fixture that basically is going to set up or populate our database with each test. In this particular case, I have a DIY project. So the first one is for like a Birch bookshelf project. And the idea here is it's going to populate 3 different tables, put data into them, and then we can run our tests from there. And same thing with the second one. It's just another project with more rows to insert into the database. So this is just pure SQL within our fixtures, and it inserts into the database. So Another thing also to notice, we're yielding the project IDs because usually when you run your test, you're probably going to use those IDs against in your test to verify various things. So now let's actually make a test to test this database. So I usually make my first test really simple just to verify a few things that I can connect to the database and so that I can make sure that PyTest is running how I want it to be running. So in this case, all this test is doing is just checking that a table exists and that I can query something from it. That's it. Nothing too complicated from that. Basically, again, just making sure that PyTest is working as expected. So now, what are we actually testing? So right now, in my database, in this project, I have 3 tables: a projects table, project supplies, and project steps table. So these 3 projects, I'm going to insert the data into them. It's just, again, a simple 3 tables storing information about projects, DIY projects. So those were the tables. Now here are the stars. We have a stored procedure called get project costs, and then another view, or a view called project and supplies. The get project costs, that is a stored procedure that is going to, you're going to pass it in project ID, and it will sum up all the costs for that project and return the total costs. The view is going to take all the project supplies and denormalize it and attach the project name to each row. Nothing complicated. Now, there are a few problems here, so shh. That's the whole point. We're trying to see those errors. So these are now tests that I'm going to use to test out my stored procedure, my tables, and my views. So the first 3 tests are just basically checking to see, do I have tables, and am I able to query them? So they're just simple selects and just checking to see if the data that I'm putting into those tables, it's actually coming back. And then the stored procedure test is the 4th, and right there we're making sure that if I pass in the Birch bookshelf project, it's coming back with $200 roughly. And then finally, the view itself, it's looking to see if I'm getting back 8 rows. Nothing complicated. There is one little wrapper though that I'm using, and it's called runsproc. Runsproc is just a simple wrapper that I'm using to execute stored procedures. So I have a call out to the database. I'm calling that execute statement, which is invoking my stored procedure, and then it returns back the actual data. So now I'm going to try it. This should be better because I use black. Let's see here. OK. So I'm just going to kind of run through what it looks like when it fails. So I'm just going to use PyTest-v. So to show the verbose side of things. What's going on? So I got some failures right off the bat. And I expected failures. So one of my problems here, let me just minimize this a little bit. So for my stored procedure test, I'm getting back $100 instead of the $200. And for my view, I'm getting 16 rows instead of 8. So something's up. So I'm going to go back to the code for the stored procedure, which isn't that great to see. Shoot, I was really not expecting that. So I'm going to just change it. The problem that I ran into was that instead of adding the quantity and the unit cost, instead of multiplying, I was adding them. And then for the view itself, actually, let me go back to this one really quick. For the view, I had a bad join condition where I was just joining this. The join condition was basically worthless. So I'm going to go and alter them. Do them one at a time. Hopefully it can connect. Or not. Wow. So I'm just going to try this one more time. Good, perfect. Second time is a charm. Also change my view, so hopefully now when I run it, let me clear this out, my tests are now passing. So the idea here was I had a bad stored procedure, a bad view, and I just had to correct an operator in my stored procedure, correct the join condition in my view, and now my tests are getting the values that they're expecting. So that is one of the strategies that I was actually using to, yeah, that would not have worked out. That's one of that was the process I used to test out things like my 4,000 line long stored procedure. Now, some benefits and drawbacks to this. The problem that I the nice thing about this approach is that it is database agnostic. So you could use this with Postgres, and I do have an example. I don't know if actually I think I might be over time, but so I probably won't be able to show it. The fixtures are reusable. The tests and fixtures can be grouped together. So the nice thing about that is I can organize everything. And finally, we can leverage Python's vast modular ecosystem. So the idea there is in some of my tests, I needed to calculate dates. I needed like the first of the month following 3 months from whenever I ran my test. So using like something like date utils relative date delta was really a great thing for me because I can make up any date and I could be pretty sure that I was going to get the same date with every test run. Also, PDB, absolutely love it. I highly recommend it. And then another thing too, you get to use with PyTest assert. So assert is basically going to let us use just normal Boolean conditions versus like unit tests where you have to reference like assert equals or greater than. I wasn't a huge fan of that framework just because I always had to go run and look up which function I wanted to use for my tests. Now, as far as a few drawbacks, maybe. This is command line based, so if you're used to a GUI, you may not like this approach. If you don't like GUIs, then you're going to like this approach. It's up to you on this. The code coverage is more or less useless, though, because PyTest is going to view those stored procedures as black boxes. It's not going to be able to see all the branches. So like I had a 4,000 long stored procedure. It's not going to see all the different branches into it. So the code coverage that comes with PyTest, it's not going to be able to see that. So that's kind of worthless here. Another thing, too, other more specific database testing tools like tsqlt, they have nice helper functions. Like tsqlt has a asserts equals table where you can populate one table, make sure it checks against another table, and you're good to go. So this was the approach that I used. I loved it, and it worked really great for me. And that's pretty much it. The code, again, can be found at my GitHub account, and I have a companion article which goes into a little bit more detail as far as using virtual envs and all that kind of stuff. So yeah, I think questions, I guess. Thanks. I apologize for the color schemes. Back?
Yeah, I had a question about the fixtures that you, like the mock data that you're creating.
Yep.
How did you, or maybe this just like took a lot of time, but like how did you consider like what to put in that data and like what use cases in order to actually get like valid tests of all the different pieces? Like, how do you keep that up to date as you're changing?
So what data that I know to put into my fixtures and how I would update it. So what I would normally do is, especially with my scenarios, like I would have specific scenarios that that would fail, right? So I had a stored procedure. It failed when, like this was all benefit administration. So if a certain employee enrolled in some plan and something else was going on, that would cause an error in my tests, or that would cause an error in real life. So I'd go back to my tests and I would handcraft all of that, all those inserts. So my fixtures, unfortunately, like if you, what I was doing was I was inserting into the database everything I needed to set up that condition. And unfortunately, if things changed, I would have to go back and change the tests as well. There are libraries that I haven't had a chance to take a look at, like Hypothesis. A lot of people were saying, hey, check this out. And that might be an approach that you might want to take a look at as far as generating data. But also another thing too, dates were a big thing with me. So like I needed to make sure that For example, this person was hired on a certain date. Well, if I hard-coded that date, in about 2 years, that person's not a new hire anymore. They've been there for 3 years. So I used things like date utils relative delta to say, okay, based on the day that we're running the tests, calculate it out like 3 months ago, take the middle of the month or something like that, depending on what I wanted to do with that particular employee's hire date, and then it'll use that. So I don't know. It's not a great answer because it's one of those things that, depending on the use case, you're going to run into issues.
For testing for environment, like when you run this, do you use just a local DB, and if you have third-party like unittest runs, like before you merge something into a master branch, like Travis or something like that, are there options to create database there as well, or do you pass it a staging environment just to have that?
So the question is, what environment would you use this in? Unfortunately, where I use this, I was it was a very small team, so I had pretty much say on what happened, and we were using it in. We had a dev database, and that would be where we would test out of it. But you could run this locally. Like this is running off of an Azure database, nothing too crazy, and I mean, it's depending on how your organization works, you're probably going to be working with your DBA. All right, stopped. Thank you all. I appreciate it.